Hey guys, sure thing. Let's talk about factor theorem now. So, remember in the previous video we were talking about the remainder theorem, right? Usually, you'd have a of x being a polynomial. If this a of x is divided by b of x, right, and b of x is cx minus d, right? We then say we take that cx minus d equals to 0, cx equals to d, x equals to d over c. Then we said that a of d over c, right, is going to give us our remainder, right? Cool. That was the remainder theorem. Now I think we can continue from the remainder theorem and try to connect it with factor theorem somehow. So with this, I would say if you still have a of x, right, and you're dividing it by b of x, right, so then if you find out that I mean, of course, b of x is a cx minus d, right? From there you're gonna solve and you're gonna find out that x equals to d over c, right? So if a of x, if a of d over c, a over d over c, what, a of d over c, if we know of course that, okay, if this gives you 0, what is it saying? It's saying that we know therefore the remainder, right, is 0, right? Yes, we know that the remainder is 0, and if the remainder is 0, this is a factor of the polynomial. Yeah, this becomes a factor of our polynomial. So let's forget about polynomials for a bit now. Let's talk about numbers, right? So remember, if we talk about factors, that a 3 is a factor of 6, right? Or generally speaking, whenever you are talking about a factor, to say this number is a factor of this particular number, we are saying these numbers, they can divide those numbers without leaving a remainder. In a sense, we are saying that the remainder is going to be 0 if you divide a by b, right? So we say that b is a remainder. No, b is a factor of a if we can divide a by b and the remainder is 0, right? Yeah, so this is, yeah, the remainder becomes 0. Yes. Cool stuff. So what then do we do, right? Cool. When you are factorizing now these polynomials, you need to know the factors of the polynomial. When you know the factors of the polynomials, it becomes way easier for you to factorize this thing, right? Cool. This is beautiful. I like where we are going. So take for an example, let me take this f of x. Let me go for black. So f of x is equals to x squared plus x minus 6, So of course we know, like, if we were to factorize this, we know you have your two brackets, you have x, you're like, okay, two numbers I multiply, I get minus 6, I add or subtract, I get plus 1. That means I have plus 3 and minus 2, right? So then you are done factorizing, but say, hey bro, I don't know, but let's say that you are in an exam room, you had the most horrible, or maybe I don't know, your house, I don't know, you got robbed yesterday or something like that, but like something bad happened and you couldn't study, you couldn't prepare, and then you happen to have forgotten like a lot. Yeah, well, you happen to have forgotten how to factorize as well. So how you would then at least have an idea of how to solve this number. Here's the thing, eh? Let's do some young inspection. Let's find f of 1, right? F of 1, that is 1 squared plus 1 minus 6, that is 2 minus 6, that is what? That is minus 4. So 1 is not a factor, right? Let's go minus 1, right? Minus 1 plus 1. Oh, it's going to be minus 1. Then minus 6, right? You have 1, minus 1, minus 6, minus 6. It's not a factor. So we go again, right? It's something I don't like this, by the way. But yeah, you got to do what you got to do to survive, bro. Plus 2 minus 6. So then I'm getting what? I'm going to get, come on, bro. That is 4 squared plus 2. Oh, no, not 4 squared, because 2 squared is 4. Yeah, so it's 4 plus 2 minus 6, right? So you're getting 6 minus 6, you're getting 0. So we have it. This, it must be a factor, right? 2 is a factor, right? But not necessarily 2 here, because we're not talking about numbers now. I'll come back to 2. I'll come back to 2. Let's see other numbers fast. Cool. Let's say the number is now minus 2, just to see. Minus 2. So minus 2 squared minus 2 minus 6. So that is what? That is 4 minus 8, which is minus 4. Right, let's go for 3 now. 3 squared minus 3 minus 6, that is 9 minus 9, which is 0. So again, this, right, must give us a factor somehow. And because it's a binomial, not a binomial, it's a trinomial, but like the highest degree is 2, so that means you need like two factors, right? Because when you solve for okay, it's a trinomial. Okay, let me use the word. When you solve for a quadratic equation and you solve for x, right, you're trying to look for the values of x where where f of x is 0, right? You're gonna get two possible numbers. So we have two factors, or two, I don't know what to call these, but they are not factors yet. They lead us to what our factors are, but they are not our factors, right? But we have two of them, so we will stop there. Right, so the thing now is for we started with 2, so for 2, ne, when you are solving, you'll be like x equals to 2, ne. You were solving for x, then you ended up with x equals to 2, but before that you had x minus 2 equals to 0, right? Yes, and the same is true here also. The same is true here, ne? You had x equals to minus 3, right? I'm seeing. I think I messed up the factorization there first. Let me. This is very heartbreaking. This is very, very heartbreaking. Very, because factorizing this, you get x minus 3, right, and x plus 2, right? Because then this, they will give you minus 6, and then when you, oh no, hell no. Yo, I was fine, bro. Yeah, I was fine, because this gotta be positive, so this then would have to stay positive, and this gotta be. So how did, okay, we try 2, so this is 2 squared, right? 2 plus 2, we have 4 here, we have 6, that is 0. Cool. Minus 3, we got minus 3 squared. I mean, doesn't matter, we're gonna get that. then minus 3. Damn, this is, oh, 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 oh. Okay, no, we are still on the right track. Yeah, I was just checking to see if things were making sense. We are still on the right track. I didn't mess it up. So here you go again, you like x plus 3 equals to 0, right? But then remember, before usually when you're solving for x, before you get here, right, you would then be having two brackets, x minus 2, x plus 3 equals to 0. So when you're solving for x, you have your trinomial, you do your two brackets, and then you will separate them. Of course, you'd have an or here, right, to say this equals to 0 or this equals to 0. Then you start solving, and then you get your values, right? So factor theorem, you would put on a couple of values. Okay. So what I want to say is that this is the factor. This in itself, it is a factor of this f of x, and x plus 3 also, it is a factor, right? So look, it's not 3 that is a factor, it's not minus 2 that is a factor, and even here, so the factor is a whole thing. X minus 2 is a factor, x plus 3 is a factor, right? So yeah, but I also want to go back now. Now go back. Say you started with this 2, ne? You started with this 2. So we're gonna cook from there. Delete. I need space. Let me remove all these things. So you find out that 2 is 2 gives us 0. So therefore you'll be like, okay, x equals to 2, x minus 2 equals to 0, and then you'd say therefore x minus 2 is a factor, right? After you've done that, you don't need to like continue to do what we did, like trying to find other values, because sometimes it could be exhausting. Sometimes you end up wasting time trying to find the next value. So now what we do is, because we have learned the polynomial, you can even use the synthetic method, right? I prefer the polynomial method, right? So I'm always going to use it. So then you have x minus 2, right? And you are factorizing x squared plus x minus 6, right? So let's go. You're like x squared divided by x, you're getting x. X times x squared minus 2x, right? Then you are doing your subtraction, 0 there. X minus 2x, that's 3x, right? 3x divided by x plus x, multiply, no, plus 3. Oh my god, come on. And I forgot to bring down the 6. So 3 times x, that is 3x. 3 times minus 2, that is minus 6, right? Then you do your subtraction and you're getting 0. What does that say? We have no remainder. Remainder is 0. And what did we say when we started? I think I removed it. But what did we say when we started? We said that if you divide a by b and the remainder is 0, then b is a factor of a, right? So we see that if we divide x squared plus x minus 6, if we divide it by x minus 2, we get 0. That means x minus 2 is a factor of x squared plus x minus 6. Do you understand? So in a way, then when we write this, then we would say that x squared plus x minus 6 is equals to x minus 2, x plus 3 plus your remainder, right? Remainder, which is what? Which is 0, right? And then remember, this is the form a of x equals to b of x, the one we divided by, multiply by q of x, our quotient, right? This is really beautiful. So that is just it about factor factor theorem. Let's do a couple of examples, see what we can get. Yeah, cool. And sometimes, so cool. Okay, you see, if this number that we are at now, if it was like this, 0 would be a factor as well, because if you substitute x being 0, you're gonna get what? You're gonna get 0, right? But now it's looking like this, so there's no way 0 can be a factor. Let's maybe try 1, right? This it's a very long thing trying to write all of that, so I'm gonna do it on a calculator. And I think I think you don't also have to like show all your workings trying to find a factor, né? Even if like you find it via your calculator and then you say that x minus 2 is a factor, then you start factorizing, I don't think you will get penalized about that. Perhaps I can say the best thing, right? Go ask your teachers if you will get penalized for doing that, but I doubt. So here you have x to the power of 3 plus x squared, right, minus 9x minus 9. So let's put in the values of x. We start with 1, right, just to see how much we get. So for 1 we're getting minus 16. It's not a factor. Let's test 2. 2 2, right, 2 is not a factor. I'm gonna try 3. If it doesn't work, I'll go to the negatives. 3 yeah, 3 works. Yeah, 3 works. Cool. So 3 works, ne? 3 to the power of 3 plus 3 minus 3. Yeah, 3 works. So now I have found out, I'm like, we have found x equals to 3, right? Therefore you have okay, x equals to 3, and therefore x minus 3 is a factor, right? X minus 3 is a factor. And then what do? You do your long division. You're like x minus 3 x squared minus 9 x minus 9. Cool. Now we start dividing. The x to the power of 3 divided by x, that is x squared, multiply x to the power of 3. Let me increase there. Yeah, x to the power of 3, and then minus 3x squared, minus, we get 0 there, of course, for brackets, we get 0 there, x minus, so it becomes 4x squared, ne? And then I bring down the rest, 9x minus 9. So this divided by x is gonna be plus 4x, multiply 4x squared, multiply 12 minus 12x, right? And now my subtraction is 0, 9 minus 12, that is 3x. I bring down the 9, so minus 9. I'm doing the division. That is come on bro, come on. Oh, that is plus positive 3. I multiply 3x minus 9, right? I do my subtraction. I'm getting 0. Bam! So I was able to, okay, we have a remainder 0 as well, verifying what we did say, that x minus 3 is a factor, right? So now we can then say therefore x to the power of 3 plus x squared minus 9x minus 9 equals to x minus 3 multiplied by x x squared plus 4x plus 3, ne? Plus our remainder, which is 0, right? So that is cool. Let me remove the 0. So now you can focus on this bracket just to see if can we further factorize this thing or not, ne? And the nicest thing is we have done factorization of trinomials. So with we have done factorization of these couple of times, so this one it won't trick us. We know the answer for this one is gonna be, let me write it with black pen, it's gonna be x plus 3 x plus 1, right? Yeah, that is beautiful. Yes, so we are done. And of course, if you are factorizing this, yeah, this is it, bro. So let's cook. For this one, let's do the same thing. You have minus 2x squared minus 5x plus 6. So now let's test the numbers. You can't start with 0, of course, because of 0 won't give you the factor. 1 1 1. Oh how lucky I was. So 1, right? So we're getting x equals to 1, right? Therefore x minus 1 equals to 0, right? And how did we write it here? I can, yeah, is a factor. X minus 1 is a factor, right? So now I do my long division again. Division. Alright, x to the 3 x squared minus 5x plus 6. Nah, so x to the power of 3 divided by, that is x squared, multiply x to the power of 3 minus x squared. Cool. I'm doing the subtraction. X squared, cool. 0 there, minus 2 x squared minus, so that is minus x squared. I bring down the rest, 5x plus 6. Let's go, x minus this divided by that is minus x. I multiply minus x plus x, this is x squared, right? Then the subtraction, that is 0 here, and then minus 5 minus x minus 6 x. I bring down the rest, that is come on, bro, what is this? 6. Then I divide, I get minus 6. I multiply, I get minus 6x minus 6. Is that really? No, it's plus, because negative and negative. Then I subtract, and I'm gonna get 0. So here it's clear, 0 is a reminder, so I do have a factor, right? Then you can say x to the power of 3 minus 2x squared minus 5x plus 6 equals to x minus 1 into x squared minus x minus 6, right? And the second bracket is quite easy. It is x minus 3 x plus 2, right? And that's it.